Hello viewers, welcome to my channel Maths with VTC. In this video class, we are going to see criteria for similarity of triangles. Already we studied the definition of similar triangles. Two triangles are said to be similar. Two conditions are to be satisfied. Their corresponding angles are equal and their corresponding sides are in the same ratio. Now what we are going to study is, can we relax any one of these conditions? Because triangles are special polygons. A polygon with minimum number of sides is triangle. Triangle has only 3 sides. So that is the first polygon. Also, sum of the angles of a triangle is 180 degree. So triangles possess these kind of characters. Therefore, can we relax these two conditions so that we can easily identify whether two triangles are similar or not? So that we are going to study in this chapter. So when two triangles ABC and DEF are similar, if the corresponding angles are equal, A corresponds to D, B corresponds to E, C corresponds to F. Therefore, their corresponding angles are equal and corresponding sides are in the same proportion. AB corresponds to the side DE, BC corresponds to the side EF, CA corresponds to the side FD. So, you note the order of the letters A, B, C, D, E, F. So, A corresponds to D, B corresponds to E, C corresponds to F. That order is important to say that triangle ABC and triangle DEF are similar. The similarity of two triangles should also be expressed symbolically using correct correspondence of their vertices. For example, you consider these two triangles ABC and DEF. So, angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. So, you can write triangle BAC is similar to triangle EDF, not in any other order. You can't write a triangle ABC is similar to triangle EDF. Of course, ABC, EDF represent the same triangles, but when you say two triangles are similar, you have to write the letters in correct order. The angles should match. The corresponding angles should be equal. In such a way, you have to write the letters. So here, you can write a triangle BAC is similar to triangle EDF, or you can write a triangle ABC is similar to triangle DEF. So in that order, you can write, not in any random order. So that will not be correct. Okay. Now, an activity. Draw two line segments BC and EF of two different lengths, say 3 cm and 5 cm respectively. Then at the points B and C respectively, construct angles PBC and QCB of some measures, say 60 degree and 40 degree. Also at the points E and F, construct angles REF and SFE of 60 and 40 degree respectively. You look at this figure. BC is 3 cm, EF is 5 cm, angle B is 60 degree, angle C is 40 degree. Similarly, angle E is 60 degree, angle F is 40 degree. Now, what you have to do is, you have to measure the length AB and DE. You find the ratio. Already the ratio between BC and EF is 3 divided by 5, which is equal to 0.6. Now you measure the ratio of the corresponding sides AB, DE. Find the length and form the ratio. AB divided by DE, you will wonder, it will also be equal to 0.6. Similarly, AC divided by DF will also be equal to 0.6. So that is the activity. Therefore, what we conclude, AB divided by DE is equal to BC divided by EF is equal to CA divided by FD. Now you keep that idea in mind and look at theorem 6.3. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportion, and hence the two triangles are similar. So if the corresponding angles are equal, then the corresponding sides are also in the same ratio. You need not verify them separately. As far as triangles are concerned, to say that they are similar, it is enough to verify whether the corresponding angles are equal or not. So that is the content of this theorem 6.3. So second condition is relaxed. So that is the character of triangles. Now you consider the triangle ABC and DEF. Now angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. In such a way, the two triangles are constructed. So triangle DEF is bigger than triangle ABC. Cut DP is equal to AB and DQ is equal to AC and join PQ. So triangle ABC is congruent to triangle DPQ because side angle side criteria, if you apply, these two triangles are congruent. Therefore, angle B is equal to angle P is equal to angle E. Therefore, what you can say, PQ is parallel to EF because angle P is equal to angle E. Therefore, PQ and EF must be parallel. Now, using theorem 6.1, you can say dP by PE is equal to dQ by QF. That is, AB by DE is equal to AC by DF. Similarly, you can prove AB by DE is equal to BC by CF, and hence AB by DE is equal to BC by EF is equal to AC by DF. This criterion is referred as angle criterion for similarity of two triangles. A criterion for similarity of two triangles. Now you still relax the condition because in triangles, when two angles are given, third angle you can find because sum of the angles is equal to 180 degree. Therefore, it is enough to compare just two angles instead of three angles. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar because automatically the third angle will be equal because sum of the angles is equal to 180. So that is the special character of triangles. Instead of verifying all the angles, it is enough to verify just two angles. So this may be referred as AA similarity criterion for two triangles. So previously we studied angle criterion. Now it has been reduced to angle criterion of similarity of triangles. Now another activity. Draw two triangles ABC and DEF such that AB is equal to 3 cm, BC is equal to 6 cm, CA is equal to 8 cm. DE is equal to 4.5 cm, EF is equal to 9 cm, and FD is equal to 12 cm. You see the figure. Now, AB by DE, what is it? 3 by 4.5. BC by EF, what is it? 6 by 9. AC by DF, what is it? 8 by 12. All are equal to 2 by 3. Therefore, all the sides are in proportion, in the same ratio. Now you measure the angle A, angle B, angle C in the first triangle, and in the second triangle you measure angle D, angle E, and angle F. You will observe that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. That is, the corresponding angles of the two triangles are equal. Therefore, now we get a new idea. Previously, we verified whether the corresponding angles are equal or not. Only If the corresponding angles are equal, then immediately we need not bother about the sides. We can say that two triangles are similar. Now we verified the ratio of the corresponding sides. They are equal. Automatically the angles are equal. Therefore, we need not verify the angles. When sides are in proportion, you can immediately say that the two triangles are similar. Remember, this is true only for triangles. Okay. Now, we put what we studied in the previous activity as a theorem. Theorem 6.4. If in two triangles, the sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar. So this criterion is called side similarity criterion. That is SSS similarity criterion for two triangles. Proof. This theorem can be proved by taking two triangles ABC and DEF such that AB by DE is equal to BC by EF is equal to AC by DF. You consider these two triangles. Now, DEF is bigger than ABC. Therefore, as we did earlier, cut DP is equal to AB and DQ is equal to AC and join PQ. Then dP by PE is equal to dQ by QF and PQ is parallel to EF. Already we discussed this fact. So angle P is equal to angle E and angle Q is equal to angle F. Therefore, dP by dE is equal to dQ by dF, which is equal to PQ by EF. So, dP by dE is equal to dQ by dF, which is equal to BC by EF. Therefore, BC equal to PQ. Thus, triangle ABC is congruent to triangle DPQ. So, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So, for two triangles, if the corresponding sides are in proportion, then immediately you can say those two triangles are similar. We need not bother about the angles. Now, another activity. Draw two triangles ABC and DEF such that AB is equal to 2 cm, angle A is equal to 50 degree, AC is equal to 4 cm, DE is equal to 3 cm, angle D is equal to 50 degree and DF is equal to 6 cm. Now, you observe that AB is 2 cm, the corresponding side DE is 3 cm, therefore the ratio is 2 by 3. Similarly, AC is 4 cm, the corresponding side DF is 6 cm, 4 by 6 is also equal to 2 by 3. Now, you have to verify the ratio BC divided by EF. You measure the length BC and you measure the length EF. You will find that BC divided by EF will also be equal to 2 by 3. Further, angle B will be equal to angle E and angle C will be equal to angle F. Therefore, you can say triangle ABC is similar to triangle DEF. Now, we put that fact in the form of theorem 6.5. If one angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then the two triangles are similar. So this criterion is referred as a side angle side similarity criterion. Now we prove this theorem. You take two triangles ABC and DEF such that AB by DE is equal to AC by DF less than 1 and angle A is equal to angle D like this. As usual, ABC is a smaller triangle, DEF is a bigger triangle. Therefore, you take points P and Q such that DP is equal to AB and DQ is equal to AC and join PQ. Now, PQ is parallel to EF and a triangle ABC is congruent to triangle DPQ. Therefore, angle A is equal to angle D, angle B is equal to angle P, and angle C is equal to angle Q. Therefore, triangle ABC is similar to triangle DEF. So, SAS criterion for similarity, side angle side. This also you have to remember. Now, examples. In figure, PQ is parallel to RS. Prove that triangle POQ is similar to triangle SOR. Given the line PQ is parallel to the line RS. We have to show that the triangle POQ is similar to SOR. You note the order of the letters of the triangle POQ, SOR. Therefore, you have to show that angle P is equal to angle S. Angle O is equal to angle O. And angle Q is equal to angle R. So, in such a way, you have to prove that. That's why it is given triangle POQ is similar to triangle SOR. Now, we are given PQ is parallel to RS. Therefore, angle P is equal to angle S. Why? Because they are alternate angles. Similarly, angle Q is equal to angle R. Why? The same reason. They are also alternate angles. Also, angle POQ is equal to angle SOR because they are vertically opposite angles. Now, what you can say? All the corresponding angles are equal. Therefore, by AAA similarity criterion, triangle POQ is similar to triangle SOR. Example 5. Observe the figure and then find angle P. So, a triangle ABC is given. Two angles are given. Angle A is equal to 80 degree, angle B is equal to 60 degree. Length of AB is equal to 3.8 units. Okay. Now, you have to find angle A corresponds to which angle? Angle P or angle Q or angle R. Similarly, you have to find angle B corresponds to which angle in the second triangle. That you have to find. Now, what I am going to do is, I find the ratio between the sides. So, AB by RQ. AB is 3.8, but RQ is 7.6. When you form the ratio, it is 1 by 2. BC is 6, PQ is 12. Ratio is 1 by 2. So, CA is 3 root 3, PR is 6 root 3, ratio is 1 by 2. Therefore, AB by RQ is equal to BC by QP is equal to CA by RP. So, triangle ABC is similar to triangle RQP. You note the order of the letters. Triangle ABC is similar to triangle RQP. You don't write PQR, it will be wrong. Okay. Now, we have to find angle P. So, it is equal to angle C. So, in the first triangle, if you find angle C, then that will be equal to angle P. But angle C is equal to 180 minus angle A minus angle B, and that is 40 degree. Therefore, angle P is also 40 degree. So, using similarity of triangles, we found the angle P. Example 6. In the figure, OA into OB is equal to OC into OD. Show that angle A is equal to angle C and angle B is equal to angle D. Solution. OA into OB is equal to OC into OD. That is given. Therefore, OA divided by OC is equal to OD divided by OB. Just by transpose of some lengths, you get this equation. OA by OC is equal to OD by OB. You call this equation as 1. Also, we have angle AOD is equal to angle COB, vertically opposite angles. Therefore, from 1 and 2, triangle AOD is similar to triangle COB. So, when you write these letters of triangle, you have to be very careful. You have to write in the correct order. Otherwise, it will be wrong. So, this is by SAS similarity criterion, side angle side. Therefore, angle A is equal to angle C and angle D is equal to angle B. Very simple. Example 7. A girl of height 90 centimeter is walking away from the base of a lamp post at a speed of 1.2 meter per second. If the lamp is 3.6 meter above the ground, find the length of a shadow after 4 seconds. You look at this picture. So AB is the lamp post. After 4 seconds from B, she came to the position D. Now you have to find out the shadow length. That is, you have to find the length of DE. Solution. Let AB denote the lamp post and CD the girl after walking for 4 seconds away from the lamp post. From the figure, you can see that DE is the shadow of the girl. Let DE be x meters because that is to be found. Now BD is equal to 1.2 into 4, which is equal to 4.8 meters. Note that in triangle ABE and triangle CDE, angle B is equal to angle D. And angle E is equal to angle E. Therefore, by AA similarity criterion, triangle AB is similar to triangle CDE. Therefore, BE divided by DE is equal to AB divided by CD. So now you put the known values in this equation. You get 4.8 plus x divided by x is equal to 3.6 divided by 0.9. So when you simplify, you get x is equal to 1.6. Therefore, the shadow of the little girl after walking for 4 seconds is 1.6 meter long. Now, example 8. In the figure, CM and RN are respectively the medians of the triangle ABC and the triangle PQR. If triangle ABC is similar to triangle PQR, prove that the following 3 results. So that is the question. So you look at the diagram, you will prove the result. You will prove one by one. Solution 1. Triangle ABC is similar to triangle PQR. Therefore, AB by PQ is equal to BC by QR is equal to CA by RB, because we are given those two triangles are similar. Therefore, the ratio of the corresponding sides are equal. So you call this equation as 1. And the corresponding angles are also equal. Angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. But AB is equal to 2 times AM because M is the midpoint of AB. Therefore, AB is twice AM and PQ is twice PN. We are given N is the midpoint of PQ. Therefore, from 1, we get 2 AM divided by 2 PN is equal to CA by RP, or AM divided by PN is equal to CA divided by RP. You call this as equation number 3. Also, angle MAC is equal to angle NPR from equation number 2. Therefore, from 3 and 4, triangle AMC and the triangle PN are similar because of the criterion SAS, side angle side. Therefore, these two triangles are similar. Now, second question. From 5, CM divided by RN is equal to CA divided by RP. You call this as equation number 6. But CA divided by RP is equal to AB divided by PQ from equation number 1. You call this as equation number 7. Therefore, CM divided by RN is equal to AB divided by PQ. That is the required result. Now, third question, it is similar to 1, therefore you can easily prove it. Now we move on to exercise 6.3. The first problem, state which pairs of triangles in the figure are similar. Write the similarity criterion used by you for answering the question and also write the pairs of similar triangles in symbolic form. So you look at the first figure, triangle ABC, triangle PQR. So all the 3 angles are given. A is 60 degree, B is 80 degree, C is 40 degree. Here P is 60 degree, Q is 80 degree, R is 40 degree. Therefore, it is very simple to say yes, because AAA similarity. All the corresponding angles are equal. Therefore, triangle ABC is similar to triangle PQR. You have to note the order ABC, PQR. Now you look at the second figure. ABC, PQR. Two triangles are given with all sides. Obviously, AB by PQ, that is 2 by 4, is equal to BC by PR, that is 2.5 by 5, which is equal to AC by PQ, which is 3 by 6. All the ratios are equal to 1 by 2. Therefore, by S similarity, triangle ABC and triangle QRP are similar. You have to write the letters in order. So, QRP, you don't write PQR, okay? Now you look at the third figure. LMP is one triangle, DEF is another triangle. All the three sides are given. You look at the first triangle and choose the minimum length. It is 2. Second triangle, it is 4. So you form the ratio, it is 2 by 4. What is the next value of 2? 2.7. Here it is 5. 2.7 divided by 5, definitely it is not equal to 1 by 2. Therefore, these two triangles are not similar. Now you look at the fourth figure. MNL is one triangle. PQR is another triangle. You are given one angle 70 degree. The corresponding sides are 2.5 and 5. Here 5 and 10. Therefore, by SAS property, therefore, by SAS similarity, you can say triangle MNL is similar to triangle QPR. Now you look at the fifth figure. ABC is given angle A is 80 degree, AB is 2.5 and opposite to the angle A, length is 3. But in the second triangle, angle 80 degree is present, angle F is 80 degree, but opposite side is not given. Therefore, we can't say anything about these two triangles. Therefore, they cannot be similar. Now you look at sixth figure. In triangle DEF, angle D is 70 degree, angle E is 80 degree. Therefore, angle F will be 30 degree. In triangle PQR, 80 degree is present, 30 degree is present. Therefore, these two triangles are similar because of the similarity criterion angle. So, triangle DEF is similar to triangle PQR. Second problem. In the figure, triangle ODC is similar to triangle OBA. Angle BOC is equal to 125 degree and angle CDO is equal to 70 degree. Find angle DOC, angle DCO and angle OAB. It is very simple. First, as angle DOC and angle BOC are supplementary angles, angle DOC is equal to 55 degree. Because 180 minus 125 is equal to 50, therefore angle DOC is equal to 55 degree. Now, two angles in the triangle ODC are known. Therefore, you can write angle DCO and it is also equal to 55 degree. Now, angle OAB and angle DCO are alternate angles. Therefore, angle OAB is also equal to 55 degree. So, the problem is very simple. Third problem. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at the point O. Using a similarity criterion for two triangles, show that OA divided by OC is equal to OB divided by OD. First, let us draw the picture for this problem. So, ABCD is a trapezium. AB and DC are parallel. Let the diagonal intersect at O. Now, angle AOB and angle DOC are vertically opposite angles, therefore they are equal. Next, angle OAB and angle OCD are alternate angles because AB and DC are parallel, therefore they are also equal. Similarly, angle OBA and angle ODC are alternate angles, therefore Angle OBA is equal to angle ODC. Therefore, triangle OAB is similar to triangle OCD. Therefore, OA divided by OC is equal to OB divided by OD. The ratio of the corresponding sides are equal. Problem number 4. In the figure, QR by QS is equal to QT by PR and angle 1 equal to angle 2. Show that triangle PQS is similar to triangle TQR. Solution. Since angle 1 equal to angle 2, triangle QPR is an isosceles triangle because opposite sides are equal. Therefore, QP is equal to PR. In the given relation, you substitute this value. Therefore, QR by QS is equal to QT by QP. That is, QR by QT is equal to QS by QP. Also, angle PQS is equal to angle TQR. Both are angle Q only. Therefore, by SAS similarity, we have triangle PQS is similar to triangle TQR. It is very simple. Problem number 5. S and T are points on sides PR and QR of a triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. You consider this triangle PQR. So S and T are points on the sides PR and QR respectively. We are given triangle TRS, angle P is equal to angle RTS and angle R is equal to angle R. Therefore, angle TSR is equal to angle Q. Now you look at the diagram carefully. So, angle TSR is equal to angle Q. Therefore, by A similarity, we have triangle PRQ is similar to triangle RTS. Problem number 6. In the figure, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. Solution. Since triangle ABE is congruent to ACD, therefore they are of same shape and same size. We have AB is equal to AC. You call this as 1. Corresponding part of congruent triangles. Similarly, AE is equal to AD. You call this as 2. Therefore, in triangle ABE and ACD, we have AB divided by AC is equal to AE divided by AD. A is the common angle. Therefore, by SAS similarity, we have triangle ABE is similar to triangle ACD. Problem number 7. In the figure, altitudes AD and CE of a triangle ABC intersect each other at the point P. Show that 4 results are given. Now you look at the diagram carefully. Let us prove one by one. In triangle AEP and triangle CDP, we have angle AEP equal to angle CDP is equal to 90 degree. By inspection, you can observe this. Also, angle APE is equal to angle CPD. They are vertically opposite angles. So, by AA similarity, we have triangle AEP is similar to triangle CDP. Next. In triangle ABD and CBE, we have angle ADB is equal to angle CEB is equal to 90 degree. Also, angle ABD is equal to angle CBE, common angle. By AA similarity, we have triangle ABD is equal to triangle CBE. So, it is very simple. That problem. In triangle AEP and triangle ADB, we have angle AEP is equal to angle ADB is equal to 90 degree. Also, angle PAE is equal to angle DAB, common angle. So, again by AA similarity, we have triangle AEP is similar to triangle ADB. Fourth problem. In triangle PDC and triangle BEC, we have angle PDC equal to angle BEC equal to 90 degree. Also, angle PCD equal to angle BCE, common angle. Therefore, again by AA similarity, we have triangle PDC is similar to triangle BEC. So, this problem is very simple. Next, eighth problem. E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. So that triangle ABE is similar to triangle CFB. You look at this diagram. ABCD is the parallelogram. AD is produced to E and BE intersects DC at F. That to show that a triangle ABE and a triangle CFB are similar. Look at the diagram. In triangle ABE and a triangle CFB, angle A is equal to angle C. Because they are opposite angles of a parallelogram, therefore they are equal. Angle AEB equal to angle CBF. Alternate interior angles as AE is parallel to BC, therefore they are equal. So by AA similarity, we have triangle ABE is similar to triangle CFB. Ninth problem. In the figure, ABC and AMP are two right angles. Right angled at B and M respectively. Prove that 1. Triangle ABC is similar to triangle AMP. 2. CA divided by PA is equal to BC divided by MP. Look at this diagram. Solution. In triangle ABC and AMP, angle ABC is equal to angle AMP, both are 90 degrees. Angle A is equal to angle A common. Therefore, by AA similarity, we have triangle ABC is similar to triangle AMP. Second question. Since the corresponding sides of similar triangles are proportional, we can directly write CA divided by PA is equal to BC divided by MP. 10th problem. CD and GH are respectively the bisectors of angle ACB and angle EFG such that D and H lie on sides AB and FE of triangle ABC and triangle EFG. If triangle ABC is similar to triangle FEG, show that the following three results. Let us see one by one. It is given that triangle ABC is similar to triangle FEG. Therefore, the corresponding angles are equal. Therefore, angle A is equal to angle F, angle B is equal to angle E, and angle ACB equal to angle FGE. Therefore, angle ACD equal to angle FGH because they are bisected angles. Similarly, angle DCB equal to angle HGE. Same reason. In triangle ACD and triangle FGH, angle A is equal to angle F and angle ACD equal to angle FGH. Therefore, by AA similarity, angle-angle similarity, we have triangle ACD and triangle FGH are similar. Therefore, CD divided by GH is equal to AC divided by FG. In triangle DCB and triangle HGE, angle DCB equal to angle HGE and angle B is equal to angle E. Therefore, angle DCB is similar to angle HGE. Same similarity criterion, angle-angle similarity criterion. Third problem. In triangle DCA and triangle HGF, angle ACD equal to angle FGH and angle A is equal to angle F. Therefore, these two triangles are similar again by the same reason. 11th problem. In the figure, E is a point on side CB produced of an isosceles triangle ABC with AB equal to AC. If AD is perpendicular to BC and EF is perpendicular to AC, show that triangle ABD is similar to triangle ECF. Solution. So we are given ABC is an isosceles triangle and AB is equal to AC. Therefore, angle ABD equal to angle ECF. In triangle ABD and triangle ECF, angle ADB equal to angle EFC. Both are equal to 90 degree. Therefore, angle BAD equal to angle CEF. By AA similarity, we can say that triangle ABD and triangle ECF are similar. 12th problem. Sides AB and BC and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of a triangle PQR. Show that triangle ABC is similar to triangle PQR. You see the picture. ABC is a triangle, AD is the median. Similarly, PQR is a triangle, PM is a median. Solution. Since median divides the opposite side, we have BD is equal to BC by 2 and QM is equal to QR by 2. So we are given AB by PQ is equal to BC by QR is equal to AD by PM because they are similar triangles. Therefore, you replace BC by 2BD and QR by 2QM. Then you get AB by PQ is equal to BD by QM is equal to AD by PM. Therefore, angle ABD equal to angle PQM, corresponding angles of similar triangles. In triangle ABC and triangle PQR, angle ABD equal to angle PQM and AB divided by PQ is equal to BC divided by QR. Therefore, by SAS similarity criterion, triangles ABC and PQR are similar. D is a point on the side BC of a triangle ABC such that angle ADC equal to angle BAC. So that CA square is equal to CB into CD. You look at this diagram. So D is a point on the side BC of a triangle ABC such that angle ADC equal to angle BAC. In the triangles ADC and BAC, angle ADC is equal to angle BAC, that is given. And angle ACD equal to angle BCA, it is a common angle. Therefore, by AA similarity criterion, angle ADC is similar to angle BAC. Therefore, corresponding sides are in proportion. So, when you write the ratio of the corresponding sides, you get CA divided by CB is equal to CD divided by CA. Thus, CA square is equal to CB into CD. 14th problem. Sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR and median PM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. So these two triangles are given. ABC, AD is the median. PQR, PM is the median. Now I complete the parallelogram for each triangle like this. Let us extend AD and PM up to point E and L respectively such that AD is equal to DE and PM is equal to ML. Now you join B and E, C and E, Q and L and R and L. We know that medians divide opposite sides. Therefore, BD is equal to DC and QM is equal to MR. Also, AD is equal to DE because it is a parallelogram. Therefore, PM is equal to ML. In quadrilateral ABC, diagonals AE and BC bisect each other at point D. Therefore, quadrilateral ABC is a parallelogram. Therefore, AC is equal to BE and AB is equal to EC because opposite sides of a parallelogram are equal. Similarly, we can prove that Quadrilateral PQLR is a parallelogram and PR is equal to QL, PQ is equal to LR. We are given that AB divided by PQ is equal to AC divided by PR is equal to AD divided by PM. Therefore, AB by PQ is equal to BE divided by QL is equal to 2AD divided by 2PM. Or AB by PQ is equal to BE by QL equal to AE by PL. By S similarity criterion, triangle ABE is similar to triangle PQL. We know that corresponding angles of similar triangles are equal. Therefore, angle BAE is equal to angle QPL. Similarly, triangle AEC is similar to triangle PLR and angle CAE is equal to angle RPL. You call this as 2. Adding equation 1 and 2, we obtain angle BAE plus angle CAE is equal to angle QPL plus angle RPL. Therefore, angle CAB is equal to angle RPQ. In triangle ABC and triangle PQR, AB by PQ is equal to AC by PR and angle CAB is equal to angle RPQ. Therefore, by SAS similarity criterion, triangle ABC is similar to triangle PQR. 15. A vertical pole of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower casts a shadow 28 meter long. Find the height of the tower. So we are going to use a similar triangle properties because the height and the shadow will be in same proportion. For any height, a shadow will be there. For different height, different shadow will be there. So the ratios of heights and the ratios of shadows will be same because they form similar triangles. So that concept we are going to use. Consider the first triangle. CD is the pole. DF is the shadow. So this is the triangle formed by pole and shadow. Next, AB is the tower. BE is the shadow which is given as 28 meters. Clearly, these two triangles are similar, but we have to prove it. Let AB and CD be a tower and a pole respectively. Let the shadow of BE and DF be shadow of AB and CD respectively. At the same time, the light rays from the sun will fall on the tower and the pole at the same angle. Therefore, angle DCF is equal to angle BAE. And angle DFC is equal to angle BEA. Angle CDF is equal to angle ABE is equal to 90 degree. Tower and pole are perpendicular to the ground, therefore the angle is 90 degree. Therefore, angle ABE is similar to angle CDF because angle criterion. Now these two triangles are similar, therefore the corresponding sides are in the same ratio. Now you can find the height of the tower like this. AB by BD is equal to BE by DF, or AB by 6 is equal to 28 by 4, or AB is equal to 42. Therefore, the height of the tower is 42 meters. 16th problem. If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB by PQ is equal to AD by PM. Let us see the picture. ABC and AD is the median. PQR is a triangle, PM is the median. Triangle ABC is similar to triangle PQR. Therefore, AB by PQ is equal to AC by PR is equal to BC by QR. Also, angle A is equal to angle P, angle B is equal to angle Q, angle C equal to angle R. Since AD and PM are medians, they will divide the opposite sides. Therefore, BD is equal to BC by 2 and QM is equal to QR by 2. So, by equations 1 and 3, we obtain AB by PQ is equal to BD by QM. In triangle ABD and triangle PQM, angle B is equal to angle Q. Therefore, triangle ABD and triangle PQM are similar by SAS similarity criterion. Thus, AB by PQ is equal to AD by PM. Thank you viewers for watching my video. Please don't forget to subscribe.